Good afternoon and Assalamu alaikum. On behalf of Oxford University Press, I, Seema Khalid, would like to welcome you all to the fourth day of this webinar week. The title of today's webinar is Developing Advanced Mathematical Skills for a Real-World Focus. Before we commence with the session, I just wanted to make you go through a few announcements that I have to make. The first one is that there will be a 6-second delay in the transmission of this session to all the participants. The second announcement is that there is a chat box that is functioning. You may want to write your comments and your questions in the chat box. We will be publishing some of them. So please feel free to add your comments and your questions there. We will address your questions in the last 15 minutes of this session. The third announcement is that all the people who have registered for this webinar will receive their e-certificates in their emails. So please keep a close eye on your email. We will soon be sending the certificates to you. It may not happen today, but in a few days you'll receive the certificates. Let us now proceed with the session. The facilitator today is Dr. Yeap Banhar. Dr. Yeap Banhar was a professor of mathematics education at National Institute of Education in Singapore. He's been teaching there for a decade. In the last 10 years, he had held concurrent positions at 2 Singapore schools as academic director at Anglo-Singapore International School and director of curriculum and teacher development at Pathlight School. He is also the consultant and author of various textbook series, including Think Mathematics. He has traveled to around 40 countries to conduct teacher professional development courses around the globe. Over to you, Dr. Yeap.
must teachers do to develop advanced mathematical skills for a real-world focus? In this session, we are going to explore that question. In Singapore's latest mathematics curriculum, which was first introduced many years ago in 1992 and has since gone through several revisions, it emphasizes on developing big ideas. Among several big ideas that the latest mathematics curriculum requires are the big ideas of functions and models. Mathematical modeling has been the emphasis since the last curriculum. In the latest curriculum, the Ministry of Education Singapore has broadened that emphasis to cover several other big ideas, some of which are in support of mathematical modeling. It is the emphasis of the curriculum that students are able, should be able, to see a real-world situation and have a mathematical perspective to it and model it, often than not using or creating a function to simulate that situation, usually to predict what might happen in the future. So our key question is, and I invite you to think about this. I say several things and give you several examples. What must we as teachers do to help students be competent in doing mathematics with a real world focus? Not to say that applied mathematics is all there is to mathematics. Obviously, pure mathematics, recreational mathematics are equally important and interesting. But for this session, we are looking at applied mathematics and what teachers can do and what school leaders must do so that we can support students to have the necessary for them to do mathematics with a real world focus. Do we help them develop an eye to see mathematics in everyday scenario? This is something I saw in our local newspaper a couple of days ago. When students look at the media and see graphics like that, do they have the eye to see mathematics? For example, in the first graph or graphics, do students think about the idea of the proportion of the two circles representing $700 and $900? Do they ask questions like, what must the ratio of the diameter be in order for the graphics to show the proportion of $900 to $700? Do they link this to what they learn in the classroom? That if the area has a ratio of 7 to 9, the diameter would not have that ratio. In other words, if I want the area of the circles to depict a ratio of 7 to 9, what must the ratio of the diameters be? I suppose that is something that the graphic artist has to grapple with. They need to know the ratio of the diameters in order to get the proportion of the circles to represent 7 to 9. Hence, relating to the idea that they learn in pie chart, do they realize that in pie chart, it is indeed the area of the sectors that actually represent the proportion? Or if they look at the second graphics, can teachers invite students to critique that graphic? This is what the graphic artist at the newspaper did. Is it accurate mathematically? Even before we talk about developing skills for students to do mathematics from the applied perspective, we must think about helping students to develop that mindset. Are our instructions such that students think that mathematics is a bunch of formula and procedures? Or do they perceive mathematics in the way that it should be? Figuring things out, being critical. The kind of classroom we cultivate on a daily basis will influence our students' belief system about the nature of mathematics. And that in turn will affect their mindset about the nature of maths. So even before we talk about developing skills, what is fundamentally important is thinking about what we do on a daily basis, the silent messages that we send out that might influence the way our students think about what mathematics is. If their perspective of the nature of mathematics is incorrect, in particular, thinking that mathematics is a set of rules, a set of procedures to be followed, listening to the teacher, mimicking the teacher, then the applied perspective, learning mathematics from the real world perspective, is quite difficult to achieve. So developing mindset about the nature of mathematics, cultivating an eye to see mathematics in everyday situation, like when they play sports. Are they able to see aspects of mathematics that is relevant? Are they able to do that? Are they able to use the relevant technological tools like GeoGebra, for example, to model mathematics? Students, are they given the opportunities to use technological tools and being given a chance to make decisions on when to use what? Or are they being told, are they being given a blanket rule? No calculators in our class, for example. Being told will impact negatively on ability to make good decisions subsequently. Given the role of technology in our everyday life today, our students must be given a chance to use a range of technological tools in the learning of mathematics, and then being guided to make good choices on when to use what. And in modeling the real world using mathematics, you do not want students to be burdened with the tedium of, for example, plotting a graph? Can they use tools to plot the graph and then spend the time they have on what we call the advanced skills? What are some of these advanced skills? In the Singapore textbooks, of which we have an edition for the Pakistan's curriculum. For example, this page is taken from the additional mathematics textbook, the latest edition. Students are exposed to the use of mathematics in a variety of contexts. If you look into the page of practice the students get, you will see tasks of different level of difficulties, from the basic, focusing on basic skills, the blue ones, to the yellow ones, which are intermediate, where the applications are somewhat familiar and commonplace, to some advanced applications. Let us take a look at one of them. A fairly basic question, modeling a phenomena in the nature, the jump of a kangaroo. The mathematics itself involves students being given an equation, a quadratic one, and that equation is supposed to model the jump of a kangaroo. And they're supposed to find the greatest height that the kangaroo can jump and the corresponding horizontal distance. The mathematics itself is not difficult. It is finding the maximum value. In this case, that value being height. And given that the expression has already been given in a suitable form, the completed square form, finding the maximum height is pedestrian. And from there, they can see what the maximum height is and when it happens. When x equals to 4, you will get the maximum height of 2 meters. And you can also see that another value that the kangaroo will be landing on the ground again. Of course, the kangaroo is on the ground when x equals to 0, which gives you 16 from the square. Another value of x that will also give you y equals to 0, meaning the kangaroo is on the ground, would be x equals to 8. In other words, that tells us that although not required by this question, it is required by this question because they want to, no, it's not. They want the horizontal distance for the greatest height. But if I want to know how far the leap is, I will be able to say that it is 8 meters, because when x equals to 8, that's when y equals to 0 once again. What I'm saying is, although the mathematics is pedestrian, given a completed square form, find the maximum height, find the corresponding horizontal distance where the maximum height occurs, and if a student wants to extend it, the student can also find the horizontal distance of the leap. Do students constantly ask questions like, what does this mean? What does y equals to 0 mean? Oh, it means that the kangaroo is on the ground. That would mean before he starts leaping and when he lands. Do students ask questions like that? Interpretation skill. Do they have that? And eventually, when they do the calculation, in this case, the maximum height being 2 meters, will they question themselves, does this make sense? That a kangaroo might jump 2 meters high? And if they are not so familiar with kangaroos, I suppose they can always Google and check if that value even makes sense. And if they extend the question the way I did earlier, I would have found out that the distance of the leap, that's 8 meters. And once again, I would question, does this make sense? These are but 2 examples of what we call advanced skills that students may need to engage in when they learn mathematics from the real world perspective. Ability to interpret, asking themselves, what does this mean? What does y equals to 0 means? What does x equals to 0 means? What does x equals to 4 entails? Asking, what does it mean? The interpretation ability. Also, the estimation skills in relation to the relevant real-world context. Does it make sense? Does the answer make sense in relation to that context? In this case, the jump of a kangaroo. These are but 2 examples of what we call the advanced skills. We call them advanced skills because these are human abilities. The computational skills, the technical part, like finding maximum and finding the value of x when maximum happens, solving for x when y equals to 0. The technical skill, that's so simple. Any machine can do those technical skills pretty easily. But the interpretation skill and the estimation skill, those are human skills. Those are things that our students really need to be good at in a technological world. Another example from the same practice I showed you earlier entails a machine, an unknown one. We don't quite know what the machine is, but the object released from that machine, the height in particular, which is represented by y, can be modeled by that expression in x. Again, a quadratic expression where x is a horizontal distance. And once again, you can see the technical work is not difficult. Finding the greatest height and the corresponding distance. Well, unlike the previous case where the expression in x has been given in a completed square form, in this case, it has not. So the students probably have to do that additional step. Or if they have learned calculus, they might find dy dx to do the same thing. But those technical skills, whether finding the differential function or the completed square form, the technical skills are easily done by machines. Of course, students can do them as well. They are not difficult. But what are the corresponding human skills that students must bring with them when they are solving this problem? I suppose it's asking questions like, what kind of machine is this? Asking questions like, was the object released from ground level? Raising questions like that. Trying to visualize, trying to imagine what is given in the abstract form, namely the equation. Can our students visualize what is actually happening when they are given something in the abstract form. That will be another example of what we might call advanced skills. Given something abstract, can they draw a diagram? Given something abstract, like the equation, can they picture in their mind? Can they visualize a possible scenario? And afterwards may engage themselves in asking questions like that. Because in this case, if they do the computation, I think the greatest height reached by the object is in excess of 40 meters. And do they know how a height of 40 meters actually look like in relation to something they might be familiar in? Say, in Karachi, the Bahria Icon Tower, I think that's about 60-something floors. Is that right? Perhaps very close to 300 meters. So that's 300 meters, pretty tall. So this greatest height is 40 meters. So it's not exactly something short. It's quite a high height that this object has reached. What kind of machine is this? Because it's not very high above the ground, it's less than 2 meters. It's only 1.8 meters above the ground when it was first projected. That's what the 9/5 represent, isn't it? So I'm in the process of giving you some examples to provoke your thinking, to make a list for yourself. What kind of things are really critical for our students to have, given that they are growing into a technological world where technical skills in mathematics, while they need to be able to do them by hand, those are no longer the sole important emphasis of mathematics. Because if we are not careful, we might be emphasizing on the technical skills and neglecting the human aspects, leaving behind our students with a bunch of rather useless skills that can be easily mechanized and done by machines. Worse, when students are immersed in a classroom that overemphasize on technical skills, they might go away with an incorrect mindset, an unproductive mindset about the nature of mathematics, and will not be able to use the mathematics they learn in their subsequent learning and in their career as a young person. In the textbook or in your lessons, you obviously want to give them a range of mathematical applications. The first one we saw was something whimsical from the nature, the kangaroo jump. The second one is probably a common thing in physics. But what about something from business and economics? Do we give them a range of applications? Do we give them a range of mathematical models being used in a variety of contexts, from something in the nature to something in the boardroom? Like here, they are given an equation, hopefully to model the profits of a company. And you see that they are being asked explicitly to explain the meaning. So these are some examples of textbook questions being written to meet the demand of a curriculum that emphasizes on mathematical modeling. Textbook authors, in this case my colleagues who wrote the textbook, they have put in questions like that, more to remind teachers that being able to explain the meaning of the various elements in an equation is pretty important. It's as important as, if not more important than, being able to find the differential function, being able to complete the square, and subsequently find for what value of x the profit is maximum. Are our students frightened of complicated looking equations? Like this one, they should not be. While in chemistry, they learn that unlike for a real gas, ideal gas, that is a relationship, pretty clean, pretty simple looking, but that is really for an ideal gas. That doesn't really exist. But you know, it's idealized for simplicity, so we can study the behavior of gases. But in real gases like oxygen or the air, the relationship between the volume, the pressure, and its temperature, the relationships are more complicated. And in this case, it's depicted by the so-called van der Waals equation. Do our students get frightened by such complicated looking equations? They should not, because the real world is complex. And more often than not, functions and equations modeling the real world, they look pretty complicated. But sometimes the complicated looking equation is pretty elegant if you have given it a chance. Do we protect our students from equations like that, which exist in other aspects of the academic world? Do we invent artificial functions for them to deal with because we are afraid that real world ones might scare them off? In a Singaporean textbook, you can see that quite a lot of the examples that are presented are harnessed from other areas in the academic world. In this case, chemistry. And because they are real, sometimes they look, at least initially, fairly complicated. But when simplified, it is within the syllabus requirement that students study in additional mathematics. I continue to invite you to ask yourself at least 2 sub-questions. What must I do as a teacher so that my students have the right mindset about the nature of nets? And the second sub-question, what are the set of human skills I want my students to have beyond the technical skills like completing the square, finding differential function, solving cubic equation, perhaps using factors theorem? Beyond those technical skills, what are the human skills I want them to have? Other examples. In this case, in sensitizing them to the world's limited resources, in this case, clean water, and taken from probably some internet sources, that is the annual water consumption per capita in an unnamed city. This is probably a model city. Do you know in the US, that value is in the range of 1,000 something cubic meters. You heard it right. That is the annual water consumption per capita in the US. Obviously, they use, or rather waste, a fair bit of water. But in this rather model city, I wonder which city that is. Places like Belgium, their values are much lower. But in this unnamed city, this has been the values over a period of about 10 years. Can they use the data to estimate or predict, rather, the water consumption next year in 2021 and beyond? And the polynomial function that they're asked to suggest, I'm sure there are multiple possibilities, and hence that is actually an open-ended question with more than one possible answer. Are our students being accustomed to such problems? What I'm trying to show here is the textbook, or in general, teachers trying to broaden the learning experience of students beyond the clean-up problems that they used to get in a more traditional setting or previously in examinations. If we continue to cocoon our students by giving them well-phrased, clean-up, unambiguous problem with one definite answer, that will not, in my opinion, helpful in creating a mindset suitable for learning mathematics and developing skills for the real world perspective. As I wrap up my lecture, I just want to show you a range of learning problems, practice problems, work examples that you and I often use in our classroom. In this case, for students probably doing more advanced mathematics, like additional mathematics, the kind of real world context that we can expose them to. Sure, as a teacher, it does take quite a lot of time for me to come up with problems like that, because I can no longer sit down at my desk and write it out, because such situation require a little bit of research on the part of the teacher. That is probably time consuming, but fear not. In a technological world, it's so easy to just go and Google and find a lot of good problems that we can use. Or for many of you who use textbooks, to find good collection of problems that pay attention to modeling the real world. This is a topic on binomial expansion. You and I know for additional mathematics, binomial expansion, binomial theorem, sometimes there's an excess emphasis on the technicality of expanding the expression raised to a certain power. Sometimes to the point where we neglect to let students see where that kind of mathematics might be useful, what kind of real world context might that mathematics model. Let me wrap up my lecture. I continue to invite you to make a list of skills that students need to have to learn mathematics from the real world perspective. I have given you some examples, such as interpretation, estimation, and so on. I have suggested how it can be done. giving them a range of real-world context modeled by mathematics, asking certain questions all the time. What does this mean? Does your answer make sense? Let me wrap up now by giving you a couple of theoretical underpinnings of what we are trying to do. Richard Scamm, his theory on mathematical understanding, reminds us that as a teacher of mathematics, we are responsible in helping our students develop the following types of understanding. They must understand the meaning of things they learn. Relational understanding, as Scamm calls it. They must also be able to interpret the symbols and notations they see, the conventions they use. Conventional understanding. When they see the negative 600, can they interpret it? They must. That is part of understanding mathematics. If they are unable to say what the negative 600 means in that context, that means they have not understood mathematics completely. Finally, they must be able to do the technicality, completing the square, solving cubic equation, and so on. Instrumental understanding. Whatever I was discussing with you in this lecture is underpinned by Richard Scamm's theory of understanding. Another learning theory that underlies everything I was sharing with you is Jerome's Gruner's theory of representation. When students learn whatever they learn, they must have learned it from a real-world context, using concrete examples. And then they model the real-world example using pictures initially, diagrams eventually. And at some point, they should be able to model the diagrams using symbols and notations, expressions and equations, functions. In this lecture, we have seen how we try to let students have a concrete case, whether it is a jump of a kangaroo or how different people might have different blood group, and modeling them using graphs, as well as functions in the symbolic representation. In this lecture, I tried to say a few things, gave you a few examples to provoke all of us into thinking two sub-questions. What kind of classrooms am I creating? I want my students to have productive mindset about the nature of nets. What must I do? Second, what are the human skills I need to develop in tandem with the technical skills? The manipulative skills, like completing the square and solving cubic equation. I thank you very much for indulging me. And our lecture today is about big abilities, advanced abilities, human competencies, some of which can be found in the list I'm showing you now. You might remember me mentioning visualization, for example. With that, I thank you very much. Have a good day.
My video is on. Can you see me?
No, not yet. Maybe 6 seconds today. Okay, you can start talking.
All right. Thank you, Dr. Yeap Har. We have with us another very seasoned educationist with us to handle the Q&A. Let me introduce Her name is Shazia Asad. Shazia Asad has is a highly experienced individual having a vast experience of 32 years. During these years, she has worked as a teacher, academic head, curriculum strategist, and curriculum organizer in various schools. She has been working with Oxford University Press since 2007. She is dealing with the curriculum and syllabus details at OUP, and she has edited different math series. She also conducts workshops at numerous training platforms. Shazia, can I start asking questions to you?
Yes.
All right.
Thank you.
Shazia, the first question is, we've received a lot of appreciation for this session. The first question that I would like to put to you is that what are the added components for teachers for this series? Do we have something like word solutions?
Yes, just like because it's a sort of a continuation with the new syllabus mathematics series. So the additional mathematics, which is actually not a compulsory subject, but taken on as an optional in the O levels, but it has exactly the same sort of format and the components that are there in the new syllabus mathematics. So we've got in the teaching guides, we have the work solutions of each and every sum that is there in the textbook. And when it comes to the workbook that we have with this textbook, we have the work solutions of the workbook in a workbook full solution added components. So for this entire series, we have 4 components altogether. So we've got the textbook and the workbook for the students. And for the teachers, we've got the teacher's resource book, which has all solutions, work solutions, and the workbook full solutions book also. And these solutions are completely formatted according to the requirements of the CAIE curriculum, the assessment criteria, the steps and the reasoning that is all there is completely computated around the assessment requirements.
Thank you, Shazia. The next question is that are the topics in this textbook covered in progression, as new syllabus mathematics has many jumps and gaps? That's what someone is commenting on. Can you just clear this comment?
Okay, so the chunks and gaps is per se, I mean, if you perceive the chunks and gaps in the new syllabus mathematics, if you're having problems, first of all, please reach out to us at Oxford University editorial department. And also number 2, it can get mitigated. It can get mitigated by you all to look through the schematic planners that are there in the teaching guide. And so you will notice that the benchmarks and the standards are across the 4 books, and they have been introduced in bite size or incrementalization, say. So if you're finding gaps, it's not because there are gaps, but because there is a link from book 1 to book 2 and then book 3 to book 4. So hopefully that can be sorted if you have some individual queries about new syllabus mathematics. As far as the textbook of additional mathematics goes, it's just one textbook, so the gaps would not be there. So just like in new syllabus mathematics, you have book 1, 2, 3, 4. So if you've stopped short in percentages in book 1 at a certain level, it just sort of takes a thread in book 2 in the financial daily life financial chapter. So I mean, and that is there in book 3 also. So it's sort of the thread continues from one book to another. So in this case, there is just one textbook, so the gaps should not be there and are not there as you would perceive it. Also, the interesting thing about this book is that because the new additional mathematics curricula has come into effect 2020, so the book that is being currently used by teachers and students has a lot of gaps. Now that existing book has a lot of gaps, and so we have made sure that we've tied in all that had to be removed or omitted in the new curriculum, like matrices and all, and relative velocity. We have removed that, and a bit of relative velocity which is put in vectors, we have put that back in. We have put in surds, we have put in APGP, which was not, those were the gaps in the existing book. So we've put in AP-GP also. We have put in the modulus of inequalities and the sketching of inequalities of cubic polynomials, the quadratic inverse. Has also been put in because it's been fleetingly mentioned in the new curriculum. The integration is there where U is ax plus b. So all these gaps that are there in the present book, which is being used by teachers and students in our Oxford University Think Additional Mathematics, all these gaps have been put in. So the velocity vector sums that were missing earlier, you will in the existing book, we've got all of that put in together.
Thank you, Shazia. The next question is, does this book tie in with the revised 2018 curriculum of AdMaths?
Yes, it does. In fact, very well. In fact, even the questions, as Dr. Yeap was also mentioning and talking about the real life connect in additional maths, which was sort of, earlier students would take it in a very abstract form. So the CPA approach is there because that's how they want. The CAIE now wants to the students and teachers to approach additional math in a more sort of holistic, realistic, real life way. So the questions that will be asked would also have the measurement and the height and the quadratics and the inequalities and the moduli that will be put in. It will have to be tied in with real life. So all that has been put in. The inspiration is all there from the latest CIE papers and all that the new parameters that they have drawn in the curriculum of additional mathematics, circular measures ho gaya, remainder factor theorem, functions, perms and coms, as in permutations and combinations. All of that has been put in because that was the gap. That is the gap in the existing book that is being used, and and we've put that in.
All right, thank you, Shazia. The next question is that, is there any plan to put all the activities of new syllabus mathematics online? Or is it available? And the comment that goes with it is that this will really help teachers who conduct online classes.
So we are going to be putting up the new syllabus mathematics series as an ebook digitally for you all so that it's easily accessible to you all on eMate, and so that it's but it's work in progress. And other than that, the Shingli resource, digital online resource, is sort of migrating to another dashboard and another sort of form. So there's been a bit of a lag there, but we have online resources which the link of which is shared in the book, and it will be operational in a couple of months. So that also for book 1, 2, 3, and 4, which is the NSM book 1, 2, and 3, 4. So in that there are a lot of activities, interactive activities for the students to sort of base their sums on and work with their sort of understanding of maths better. So that is also work in progress, and hopefully by a couple of months both will be in order. The e-files, the e-books, and the activities.
All right, thank you, Shazia, so much for your time and answering the questions of the participants. To all the people who joined us, thank you for joining us. Please register for the next 3 days that we have our webinars. So we have another one tomorrow, one on Saturday and one on Monday. So you just have to go to the same registration link if you wish to register for the webinars. The certificates will take a while to come to you. So thank you so much, everyone, for joining us.